Welcome to Pathan Sir Chemistry class. Today we'll discuss third order reaction with equal concentration of all reactants. Okay. Now let us consider a reaction of the type 3A gives product. Okay. Then as it is a third order reaction and all the reactants have equal concentration. Okay. So when time T was 0, let us consider the initial concentration of A as small a and that of product is 0. Now reaction proceeds at some time T is equals to T. The remaining concentration of reactant is A minus X and that of product is say X. Okay. Now as it is a third order reaction, therefore the rate of reaction is equals to, in terms of product, it is plus dx upon dt is equals to K3 into A minus X to the power 3. Okay. Here this K3 is rate constant. K3 is rate constant for the reaction. Okay. Then separating variables, we get now X terms towards one side and dt terms towards another side. So it is dx upon A minus X to the power 3 is equals to K3 into dt, and then on integrating we get integration of dx upon A minus X to the power 3 is equals to K3 is a constant, it is integration of dt. So integration of dx upon A minus X to the power 3 is 1 upon 2 times A minus X square is equals to K3 as it is. Okay, integration of dt is t and it is an infinite integration. We'll introduce some constant, say c. Then we'll find the value of c putting initial conditions that at t is equals to 0 the x will be 0. Therefore put the values as 1 upon 2 times A minus 0 square is equals to K3 into T. Instead of T put 0 plus C. Okay, so that implies value of C is equals to, it is 1 upon 2, A minus 0 means A square. So it is 1 upon 2 A square is the value of C. So this equation number 2 and this one is C. Equation number 3. Substitute the value of C from equation number 3 into equation number 2. We get 1 upon 2 times A minus X square is equals to K3T plus C. So value of C 1 upon 2A square. Therefore K3T is equals to, take this value to right hand to left hand, then it is 1 upon 2 times A minus X square minus 1 upon 2A square. Okay, now simplify it. So it is 2A square minus 2 times A minus X square divided by 2 times A minus X square into 2A square. Okay, make 2 common. So if you take 2 common, it is 2 common, A square minus A minus X square divided by 2 times A minus X square into 2A square. So 2 cancelled, then K3T is equals to, okay, so this 2 is cancelled, it is A square minus in bracket A minus X square divided by 2 times A minus X square into A square. Okay, then expand this bracket, it will be A square minus in bracket A square minus 2AX plus X square divided by 2A square into A minus X square, then it is A square minus, it will becomes A square minus A square plus 2AX minus X square divided by 2A square into A minus X square. This a square plus a square minus cancelled. Then we'll get it is 2ax minus x square divided by 2a square into a minus x square. Okay, now take this x common, then it will be x in bracket 2a minus x divided by 2a square into a minus x square. Okay, and last take this t towards this side, then k3 is equals to 1 upon 2 t a square into x into 2a minus x divided by a minus x square. This expression number 4 is third order rate expression. Let us discuss characteristics of third order reaction, then its examples. So characteristic number 1 is our unit of rate constant K3. Okay, now we have already derived that K3 is equals to 1 upon 2Ta square into x into 2a minus x divided by a minus x square. Okay, now the unit for this rate constant K3 can be derived as, if you see this example, see 1 upon 2 don't have any units, t have a unit of time, say seconds, a square is a concentration, so it is concentration square into this x unit of concentration. Then again 2a minus x is a single term, its units concentration, then divided by a minus x square, then concentration square. So concentration square cancelled. We have unit as 1 upon time or second into concentration square. Now I already put time unit as second and concentration units are moles per liter, therefore it will be moles per liter square. The units are per second liter square into per mole square, or you can write it as a liter square per mole square per second. This is characteristic number 1. The unit of K3 are liter square per mole square per second. This is first characteristics of third order reaction. Okay, now let us go for the second, that is half-life of third order reaction or relationship between K3 and half-life. Okay, now the time required to complete a definite fraction of the reaction of third order reaction is inversely proportional to initial concentration square. Okay, that means this time, say, required to complete 50%, half of the reaction is inversely proportional to initial concentration square A. Okay, so T half is inversely proportional to A square, or T half is proportional to 1 upon A square. Okay, so this is characteristic number 2. You have K3 as K3 is equals to 1 upon 2Ta square into x into 2a minus x divided by a minus x square. Okay, now when time t is t half, then at that time x will be 50%, a by 2. Substitute these values into that equation, then K3 is equals to 1 upon 2 t half into a square, as it is, into x. Instead of x, write a by 2 in bracket 2a minus x means again a by 2 divided by a minus x means a minus a by 2 square. Okay, if you solve it, it is 2 times t half into a square. Okay, then this a by 2 remains, this 2a minus a by 2 is equals to 3 by 2 a minus a by 2 is equals to a by 2 square is a square divided by 4. Okay, so this a into a square, this a square get cancelled, this 4. Okay, and these 2 into 2, 4 get cancelled. It becomes 3 divided by 2 into T half into 1 upon A square, okay, which is equals to K3, or simply T half therefore is equals to 3 divided by 2 K3 into 1 upon A square, or T half is directly proportional to 1 upon A square. Okay, let us see some examples. Example number 1 in a gaseous phase. Gas phase examples. The first example is the reaction between nitrous oxide and chlorine. So 2NO react with the chlorine with the formation of 2NOCl. Okay. The second example is again 2NO plus bromine with the formation of 2NOBr. Third example is a reaction between 2NO and oxygen that will produce 2NO2. The next example is 2NO react with a hydrogen. 2NO react with hydrogen with the formation of N2O plus H2O, and next example is 2NO react with the same deuterium with the formation of N2O and N2. Okay, so these are some examples, okay, which are gas phase examples that shows third order rate expression. Okay, now reactions in solution. The first reaction that was actually proposed by Noyce and Cottle showed that the reduction of ferric chloride by tin chloride, reduction of ferric chloride by tin chloride follows third order rate expression. And the second reaction is the reaction between potassium oxalate and mercury chloride. So Hg2Cl2 is a mercury chloride. When it is treated with the potassium oxalate K2C2O4, it gives 2KCl plus 2CO2 plus calomel. This is another example which follows third order rate expression.